7.2 is over areas of circles and their sectors. Okay, you're going to learn one more formula before we finish for our quiz and test. You should learn, we're going to learn three things. One you have already, and it's use the formula for the area of a circle. It's been really depressing this morning. Students do not know the area formula for a circle. What is the area of a circle? Pi r squared. Thank you, Lord. There is hope for the future. Pi r squared, if you do not know that.
Wait, oh, yeah.
Yeah, you didn't know that. You look at your card.
No, I didn't know that.
Population density, we're actually not going to do yet. We're going to do it later on. Find areas of sectors. That is what we're doing today. And then use area of sectors. So those two things we're going to be doing today for a couple minutes. This is in page 321 of your student journal. It's also just on that page of notes that you have. So the only thing you really need are notes and a calculator and your formula card. Okay? So using the area, the formula for the area of the circle, the formula is written down here. A equals pi r squared. So what you're going to be doing today is you're going to be finding a portion of the area. Okay? And it's called a sector. A sector of a circle is the region bounded by two radii of the circle and their intercepted arc. So most of you don't read math very well, so we're going to see it. So you see this circle?
Yes.
Okay. The area of the circle, it's really hard to look at it or see it if you're not looking. The area of the circle is all that's inside of it, right? All this stuff. Am I right or am I right?
You are.
I'm 100% right. So a sector is a portion of it. So a sector would be, you see the shaded area? That's a sector of the area, okay? So it's a tiny piece of it, okay? Because everyone okay with the word sector. It sounds like rocket science, but it's a piece of the area. That makes sense? Can I get a nod? Can we get like a no? Okay. All right, so there's going to be a formula like that we had here. You're going to write it down, the area of the sector over the, and I write area of the circle, equals the measure of the arc over 360. So this formula is super close to the other formula. If you don't agree, then you don't know the other formula very well. So just like the other one, the first fraction, again, is in length. So it's going to be in inches squared or meters squared, centimeters squared, so on and so forth.
What's APB?
APB is the arc.
Oh.
Or actually the angle. APB. All right, and the second fraction, what do we say that fraction is in? Degrees, thank you. It's also written on the wall. So first fraction is in length, second fraction is in degrees. It's very similar to the arc length formula, except we're doing with area.
Wait. Area of O? What is that?
Circle. Area of a circle. You can write the word circle, I just was writing fast. Is it a formula? So can you put it on your formula card?
I didn't know.
Okay, so we are going to do a problem together. It looks like this. Here's what I want you to write, a little bit of a note on this problem. So you should have already opened up your notes. This is like 3 pages in, so if you have not yet done that, it's depressing. Okay, so find the areas of the sectors formed by angle UTV. So what does areas mean to me? And sectors? So you're going to find more than one. You're actually going to find 2. What it means is find the sectors formed by angle, what is it, UTV. All right, so it forms 2 sectors. It looks like a Pac-Man. Forms the blue one, and everyone has argued with me, but on my screen it's like an orangish pink peach. And then there's this one, the orange one. So you're going to find the area of both. Okay? So we're going to start. Would you like to do the blue first or the orange first?
The blue.
I'm going to pick the orange first. Sorry. Here's why.
Yeah.
The orange has one less step for now, and I'll explain that. So the orange sector. So your test and quiz will obviously be in black and white. So you call it white, gray, shaded, whatever. Yeah, shaded and white is fine with me. You can't name them anything else. Well, actually, here you can. They put a dot. So even more sophisticated, you can call this sector UV. The other one would be sector USV or VSU. Do you see that? Okay. So we're going to find the area of the sector. All right, so we're going to use our formula. Area of the sector goes on top. Area of the circle goes on the bottom. Just going to draw a circle. If you don't like it, and that's your problem. E equals the measure of the arc over 360. So here we plug in. Do we know the measure of the sector that we're finding, the orange one, UV? No. It would be in degrees, and it would say inches squared, or, sorry, it would not be in degrees. It would be in inches squared or meters squared here. Since this is in inches, the radius, this answer would be in inches squared. So we don't know that. By the looks of this, we don't know the area of the circle. Could we find the area of the circle? What is the formula for area of the circle? Pi r squared. What does r represent?
Radius.
Radius. Do we know the radius?
Yes.
Yeah, 8 squared. You're going to leave it in terms of pi. Leave it an exact value in the middle of the problem. This way you don't have to round in the middle of the problem. Okay? What is 8 squared?
64.
So this area is 64 pi. We're going to leave it like that. We're not going to hit S to D. We're going to leave it as 64 pi. Is everyone okay with that? Okay. We're leaving it like this. We're not rounding in the middle of the problem. We're just going to use 64 pi. What is the measure of the orange arc, the measure of UV?
70.
70 degrees out of how many? 360 degrees. All right, so what is happening to x?
It is being divided.
It's being divided by 64 pi. What is the opposite of dividing by 64 pi?
Multiplying by 60.
Multiplying by 64 pi. So you're going to do both sides. I want each of you to type this in your calculator. Do not yell out the answer. You can write it down. Reason being, a lot of you just wait for someone else to do it, and your quiz time, you're going to have no idea how to plug it in your calculator. So I want you to do it. All right, so round it to the nearest. We can do hundredth. What is it? 39.1.
Is this how it's supposed to come out?
39.1. And it is in inches squared. I'll come to you.
Oh, never mind, guys.
Yeah, you got it. Are there any questions on this first sector? It's not the length, it's the area. So the area of all of this orange. All right, so we're going to do the same thing for the second. So again, whenever you see areas and sectors, you're going to have two answers. All right, so number 2, so the second part, you can put baby, whatever you want to put. We're going to find the sector of, you can call it USV or VSU, it doesn't matter. But this is so I can tell your answers apart. Okay? All right, so we're going to use our formula. Area of the sector over the area of the circle equals the measure of an arc out of 360. So this is where some students struggle a little bit. Do we know the area of the sector?
No.
No, because that's what they told us to find, so no. Do we know the area of the circle?
No. On one part.
We do. It's the area of the whole circle. So what's the area of the whole circle? 64 pi still. It's not going to change. Same circle. What we're finding now is the area of the blue portion. Okay? What is the measure of the arc of the blue? It is not 70 degrees. It's 290. How did you find 290? Yeah. So there's 360 degrees total in a circle. Subtract 70 and you get 290. So that's the blue's measure, 290 out of 360. All right, so now what do we do from here?
Multiply by 64 pi.
Multiply by 64 pi, both of them. Should this answer be smaller or bigger than the first answer? Bigger, because it's the blue, and the blue is a lot larger.
Wait. Okay.
Let's go to this corrector. So you should get 161.97. And it is in still inches squared. Where am I getting inches from?
From the 8.
Where are we getting?
From the 8. What is this 8 called?
Radius.
The radius. From the radius.
What about super?
Questions on this? Okay? So I'm going to do one more with you, and then you're going to do 2 by yourself. Okay? This is different. This is using the area of a sector. So it says find the area of circle V. So am I finding the area of a part of it or the whole thing? Of the whole thing. We're going to use the same formula, the area of the sector over the area of the circle equals the measure of an arc out of 360. So same formula. Sorry, I'm trying to copy this for later. Same formula. What is the area of the sector? 35. You can tell because it says meters squared, and it also says A equals. A says area. Do you know the area of the whole circle? No. Do we know the radius? No. We got nothing going for us. So you can write X, because we don't know it. All right, and it equals the measure of the arc. Okay, so the arc that's given to us from T to U, what does that measure? 40 out of how many? 360. All right, so X is on the bottom. Can we just multiply by 35?
No.
No, we have to cross multiply this time. So we'll get 40X. I don't remember this one. 35 times 360.
12,600.
Yeah. Divide by 40. 315, right?
Yes.
Meters. Yeah, meters squared. You want me to go, what? You guys are going to do these too. Obviously on your paper you already have the answers, but you should be doing the work to get the answers. So use the formula like you know to do. On the first, it says areas of sectors formed by PQR. So how many answers should you have? 2. 2 of them. Okay? This one you can say the area of the shaded and the area of the white because there's no extra letter there. Okay? The second, there's going to be 1 answer. Go ahead and try them. Okay. So in the first problem, there is no bruh. Yeah, ma'am. Okay, so I'm going to just paste this in. Do we want to find the area of the shaded or of the white first?
White.
I mean, the easiest part is the shaded right now. We can find the white second. So the area of the sector. Clayton, is your phone up? Yeah, I would put it up. Do we know the area of the shaded?
Yes.
No, you don't. You're looking for it. It says find the area of the sectors. The sectors are the shaded and non-shaded areas. So you don't know it.
I was doing the wrong problem.
Over the area of the circle. So we're going to go over here. Area equals pi times r squared. What is r, our radius here? 4. So our 16 pi equals the shaded, where I'm doing the shaded first. So 140 over 360. Multiply both sides by 16 pi. So x equals, what's the answer? Point what?
5.
55 centimeters squared. Could be, could be. The white, do we use a different formula? No, we use the same formula. What is the area of the sector? Do we know? No. What is the area of the whole circle? 16 pi still. All right, and it equals, what is the measure of this arc? 220. How'd you find 220? A whole circle is 360 minus 140 is 220. So 220 out of 360. All right, so then what would I do from here? All right, so what do we get for x? What? There you go. Questions on this first one? Okay, this second, I'm going to erase this so I have room. The second, how many answers are we going to have? One. All right, what is the area of the sector? 4.1. Do we know the area of the circle? So we can call it x. And it equals, what is the measure of the arc? Over. Can I just multiply both sides by 4.1? No, what do I need to do? Cross multiply. So you get 25x. What is 4.1 times 360? Sorry. Can you see that better? Maybe not. 1476, you said? Divide by 25. What does x equal? Questions, comments, concerns about this? Will everyone be able to use this on their quiz tomorrow? Okay. All right. 11.4. So here's what's going to happen. 11.4 is like me being really nice, and it's like half your quiz, and it's no math. So if you're not good at math, you should definitely study this. Okay? Three-dimensional figures.
Oh, you said this is half of yours?
Yep, it's half. There's 20 questions. I'm pretty sure these are either 9 or 11 of them. Couldn't remember. Either way, it's either about half or over half. So, three-dimensional figures, that means there's no formulas on this. You're just going to have to understand what we're talking about here. All right, so what you'll learn to classify solids. Okay, if you don't know hexagon, heptagon, octagon, you need to review those for yourself. You're going to describe cross sections, and then we'll do that at a later date. This is page 331 of your student journal, but also on your notes page. So, a solid, okay, is a three-dimensional figure. So, solids are what you see in everyday life because almost everything, is in 3D. It is bounded by flat or curved surfaces that enclose a single region. What that means, this looks like, well, a weird-looking jump box, but there's area in between all of these lines. So it's like the orangish, tannish portion. There's area between there. You could fit something under there. You could fit water in there, things like that. Okay, a polyhedron. You're going to have to know what a polyhedron is, and I'm going to explain it to you. So if you're a highlighter, I suggest you highlight this because half of your homework asks, is this a polyhedron? If so, what kind? A polyhedron is a solid that is bounded by polygons called faces. Well, a lot of you are really unsure about the definition of a polygon. Can anybody, in layman's terms?
A polygon is a figure that has no curves and is open.
Whoa. Step.
Is that on the board and I don't know it?
Was he correct?
That was correct.
Yeah, I am correct.
Figure has no curves. And it's closed.
She told me it's on the board.
So what that means is, so a triangle is a polygon because it's made up of 3 straight lines. They have to be closed, so it's not like you can have this U-looking thing. That's made up of straight lines, but is it closed? No. Your dog would be able to get out if this were like a fence or a box or something. Don't know why you'd box your dog up, but there it is. So, polyhedron is a solid that is bounded by polygons. Okay? An edge of a polygon. So it's going to describe this. An edge of a polygon is a line segment formed by the intersection of two faces. A vertex of a polygon is a point where three or more edges meet, which is right here. The vertex are literally the corners. Edges are the straight lines. Faces are the flat parts. Okay? Is everyone okay with the terminology here? You are okay? The plural of polyhedron is a polyhedra or polyhedras. Don't ask me why. I don't teach English. Well, that's what we call them. Not drones. Polyhedras. So, there are two types to polyhedras. So here's what your homework is going to ask, and I'm going to try to help you. It's going to say, is this a polyhedron? And you're going to say yes or no. If it's a no, you're done with the question. There's only one of them that's a no. So don't even write no on all of them.
Dang.
Yeah.
She told us.
The rest of them, you're going to say yes. So focus. This is not rocket science. You're going to say yes. There are two types of polyhedra, and you need to write both of them down. The first type is a prism, and the second type is a pyramid. Go ahead and write those down. Write them down. That would help you. You can just write them down. There's two types, a prism and a pyramid. If you understand what they are, then you don't need to draw them. I can describe them to you. Okay? I also have a ton of examples. Did you write these down? Two types? A pyramid and a prism? I sure hope so. That's good. So, a prism is the first one. It's the one that you see most often in life. If you've ever had one of those, I think they're called Toblerone or something. You know what I'm talking about? The candy. It's like toffee and stuff like that, I think. I don't eat it, but my sister does. That is called a triangular prism. So what I have in my hand is a prism. In my right hand, that's your, what is your left? And this is your right. This is a pyramid. This is a prism. Okay? The difference. Pyramids come to a point. Prisms have the same base on the top and on the bottom. Okay? The base of this is called a triangle. The way you can figure out what the base is, the bases are completely congruent to each other. There's going to be a paragraph at the bottom of this, and it'll pop up and it'll tell you that the bases are congruent to each other. They're separated by a straight line. Okay? So prisms do not come to a point. Pyramids, they do. Pyramids, whatever the base is, the base will always be across from the point where they come together. Whatever shape the base is, that's what kind of pyramid it is. So what kind of base is this?
Triangle.
So this is a triangular pyramid. Okay? Whereas the other that I have, okay, it does not come to a point, which makes it a prism. What are the two bases shaped like?
Square.
Triangles. There are only going to be two bases. They're right here and right here. So this is a triangular prism. Okay, does that make sense? So we can talk about prisms more. I have quite a few of them. Let's see.
Oh, it is.
Got this?
You got it twisted.
It's not a hexagon? How can you tell without even, counting?
Counting the sides.
How many sides are there? 5. So what is a 5-sided figure? Pentagon. So this is a pentagonal prism. Pentagonal. What about this one?
5. That's 6.
6 sides. So it's a hexagonal prism. Okay? You can tell because there are only 2 pentagons and a bunch of rectangles. So the only time you're ever going to have a rectangular prism is when all of the sides are rectangles. All of them. Okay? So you're going to be asked, is this a polyhedra? If so, classify it. So you're going to have to tell me if it's a prism or a pyramid, and then you're going to have to tell me what shape the base is. Does everyone think they can do that? Yes, no, maybe so. What's confusing?
It does sound a little like. I have to see the first one.
Okay, that's fine. Not polyhedra. So there are 3 non-polyhedras. Go ahead and write them down. We'll talk about them. Not a sphere, it's a sphere.
That works like a
So a cylinder, you've seen in your life, cylinders are like cans of soup.
Yeah.
Okay? A lot of cups are cylinders. Silos are cylinders. Y'all probably don't know what a silo is. Y'all are from the silo. S-I-L-O.
Like
You guys are-
Fortnite.
You guys are from Simplicity. Cones. You've seen cones? That's what we call an ice cream cone because it is literally a cone. Christian, please focus. A sphere. Most of you play sports or have seen a sport in your life, and they're used, except for football, with a sphere. Okay? So, it's going to say, is it a polyhedra? If it has any circular surface, okay, so a cylinder is not a polyhedra because it has a circle as a base. Cone, again, circle as a base. And a sphere isn't made up of any polygons whatsoever. It is just a sphere.
So what
Like
shape
the
do you
globe.
classify football? What is that?
It's like a bunch of shapes put together. It's like its own shape. I don't know. We can Google it. I've never actually questioned it.
What did you
It's
ask
just been a
me?
football. He asked what shape a football is. I don't think that
What shape do you classify?
It's about to say
it's not really an oval. Ovals don't come to like a point, and
Oval's
footballs.
It's an oval.
Oval's rounded.
Ovals, no, that is the closest I would say, but ovals don't come like footballs. Not that like, it's like a pointy point, but it's you know what I mean. We can Google it after. That's a very good question.
It's an oval pyramid.
Okay, so to name a prism or a base, you name the prism or a pyramid. You name the base with it. Okay, so we're gonna do some examples. These are the two that are blocked out. This has a base of a pentagon. So if you've ever seen, was it UFC fighting? It's an octagon. That's an octagonal prism because there are only two bases. They're parallel to each other. They're congruent in every way, shape, and form. This is a pentagonal prism. This one, like I showed you, is a triangular pyramid. Comes to a point. The base is always directly across from that point. Okay, so we're going to do some together in your notes. So go in your notes, flip over. Do not overthink this. Polyhedrons are made up of polygons. Letter A, is this a polyhedron?
Yes.
Yes. Yes, it is. It's made up of rectangles. That's it.
Is it a prism?
It is a prism because it does not come to a point. It has two bases that are parallel to each other. So you want to write what kind of prism it is. It gave you a hint with writing these. Is this a square or a rectangle?
Rectangular
This is a
prism.
rectangular prism. That is all I'm going to ask of you. Your book writes a big, long, beautiful sentence. 2 sentences. I just want you to say yes, and it's a rectangular prism. Okay? The two bases will always be pushed away from each other. Y'all see that? It's like they were one, and then they were pushed away by these straight lines. Okay?
You can count the sides.
What do you mean count the sides?
Didn't you say like
Well, you can tell this is a rectangle, right? There's 4 sides.
yeah.
If there were 5 sides, that'd be a pentagonal prism. If there were 6 sides, that would be... That's what I'm saying. When I pulled out,
Oh,
you guys need to focus.
4 sides is a ring.
Yeah, when I pulled this out, you guys were like, hexagon. And you hadn't even counted. You just were like, it's a hexagon. You know, these you have to count. A rectangle is a rectangle. Number 6. Is it a polyhedron?
Yes.
6. Letter B. 6. It is a polyhedron. Is it a prism or a pyramid?
Hexagonal pyramid.
It's a pyramid. And what kind of base does it have?
Hexagon.
A hexagon. It has 1, 2, 3, 4, 5, 6 sides. So yes, hexagonal pyramid. Okay, again, that has really long, beautiful sentences. Well, you just need yes, hexagonal pyramid. Letter C. No, why is it not?
Because it has curves like a circle.
Got curves. The cone has a curved surface, so it is not a polyhedron. All right, we're going to keep going. This is the hardest one, number 1. It says, tell whether the solid is a polyhedron, period. If it is, name the polyhedron. So it's saying in terms of polyhedra. So this one's hard. I actually played a game the other day, a board game. It's Jumanji. So it's based off of the movie. It had an 8-sided die that looked exactly like this. Here's what's going to happen. You count the sides on a polyhedron. So here's 1. There's 2 on that side, and 3 on that side, and 4 on this side. Does everyone see it? I know it's 3D, so it's hard. So there's its first face, the one that's towards you. There's the one facing,
Oh yeah.
was that your left? There's one back here, and then there's one facing the right. Does everyone see that? There's 4 of them. So it's like,
It's like 2 pyramids stacked on top.
yep. So if there's 4 on the top, how many of them are on the bottom? 4. So what is the prefix for 4? What's 4 plus 4 is 8. What's a prefix for 8?
Oct.
Octa. So this is called a octahedron.
What?
Yes. So listen. This part will be octahedron. This will be, listen. This part will be multiple choice on your quiz, like this little section. When I got into college and I told my advisor I wanted to teach math, his first question was, what was a tetrahedron? Tetrahedron.
That's 12, ain't it?
Yeah, it's 12. So it's a 12-sided polyhedron. I don't know why anybody would need to know that. I've only ever seen one in my life, and it was made up of paper plates. And it was, yeah, my teacher in high school, I don't know, she just asked us to make it, so we did. Me and a partner, we took 12 plates, and we made them. It was really hard. It was really difficult. Anyways.
Did you succeed?
Oh, yeah. It looks like a, there's something in science that is 12-sided, so I can't say that nothing in life is 12-sided. It's just in math.
Sounds like a monster.
Anyways, 2, is it a polyhedron?
No.
It is not? No. As a curved surface, I thought this was an inner tube. Somebody said it was a donut. I mean, whatever you want it to be, that is what it is. Okay, this is the last portion. We are almost finished. You should really like this section because all you're telling me is what the shape of the cross section is. Okay, a cross section is the intersection of the plane and the solid. So looking at these 3 examples, so do you see how they took like a piece of paper and they sliced through the shape?
Yeah.
If you look at the shaded area, that's all you're doing. You're telling me the shape of the shaded area. What shape is this?
A square.
The shape of the second.
Triangle.
The shape of the third. It's a triangle. So y'all see that? You're going to... You guys need to stop talking so much.
How is that a triangle?
You see this little shaded part? It's a little purplish.
He cut it diagonally.
Well, he threw the paper in. Not through. It's only right here. You see, like, if you were up close, I don't know if you can see, but this is the light blue. And this is like the, I don't know, purplish blue. See what I'm saying? So it's like taking a piece of paper and slicing through a shape. All you're going to tell me is what shape it makes. Okay? So you should see this. You should like this section because it's like a little bit of relaxing of your brain. Letter A. You're looking at the shape formed by the intersection of the solid and the plane. This piece of paper is a plane. So what is the shaded region? What shape is that? Hexagon. That's all you tell me. That's all it is. Letter B. Triangle. Okay, again, you're just looking at the shaded region. Letter C is hard to see. If you were to turn the cylinder, it is a what? Rectangle. If you were to turn the cylinder this way, you would have a rectangle. Letter D, circle. Your options are like circle, square, triangle. It is a cone, but you're looking at the shaded region only. You're not telling me what the figure is. That is a cone, but I'm asking about that portion. Letter C, or E, sorry. Circle. And then letter F is the hardest. Look at that.
That's definitely a
What would we do
square.
if we didn't have plane? It's a trapezoid. How's that a square?
Wait, what is it?
It's a trapezoid.
It's a trapezoid. A trapezoid, listen. A trapezoid is a quadrilateral with one pair.
You got 4 sides.
Devin. A trapezoid is a quadrilateral with one pair of parallel sides. So the top and the bottom, even though my lines don't look straight, they're parallel to each other. These two are not. Okay, so you can have a trapezoid that looks like that. You can have a trapezoid that looks like this. Okay, these two sides being parallel. These two sides, it literally does not matter what they do in their life. Does that make sense? So one pair of parallel sides. Alright, are there any questions on this? Okay, we're going to do the last 2 pages. Number 3, describe the cross-section formed by the intersection of the plane and solid. Again, this is in your student journal, but you can do it on your paper. It is a square. Number 4, it's a triangle. This one? No.
I'm gonna run
So a square is a rhombus, but square is the most particular name. You're not going to use the word rhombus here, or parallelogram.
But it could be a rhombus, right?
No.
You'd be wrong.
The basis, but the reason being, if you were an architect and you had to form a pyramid and you had a what did you say? A rhombus? Rhombus is a type of parallelogram. It's not going to make all of the sides come together at one point. Does that make sense? Number 5. Number 5, what kind of cross section is that one?
Up 1, 6.
What?
Oh, 5. Oh, triangle.
A square.
Trapezoid.
Yes.
Wow.
She said triangle.
Listen, parallel side. Parallel side. Not parallel, definitely not parallel.
Hey, that's great.
Trapezoid. Trapezoid is the hardest for most students to see.
Why do they put it the same color?
Because it's in black and white, there's only so many shades of gray. 6.
Heptagon.
No, hexagon.
With a E.
Hexagon.
Heptagon. It's gotta be a heptagon.
That definitely set aside.
What?
Oh,
It's a
1, 2, 3, 4, 5, 6, 7. Heptagon. Mr. Brooks is correct.
Hey, and she clapped for me too. That's
I
bad.
did, because you were very confident and I'm proud. Alright, so you are going to
Start your homework backwards.
listen. You're going to begin your homework. I'm going to walk around and pick up your formula cards. If you want to write down any of the formulas for you to work on your homework, I suggest you do that now. I'm going to take them up. Make sure your name is on, put them on the back or somewhere very, very visible, like highlighted,